So, good evening and welcome to the first seminar in the seminar series organized by the Center for Technology, Foresight and Policy CTFP at IIT Jodhpur. It is our pleasure to have Professor Surjit Sen as our first speaker in the seminar series. His talk is titled Sustainable Cities as Ultimate Complex Systems. So Professor Surjit Sen is a professor of physics at the State University of New York at Buffalo since 1993. He is a theoretical statistical and nonlinear physicist. He earned a PhD working on statistical mechanics at the University of Georgia, which was followed by postdoc appointments at the University of Minnesota and Michigan State University. Professor Sen was also recently a distinguished visiting professor at IIT Jodhpur since 2023. He is a fellow of the American Physical Society APS and the American Association for the Advancement of Science. He was a Fulbright Nehru Fellow in India in 2017-18 and a Jefferson Science Fellow of the US National Academies in 2020-2021. In his spare time, he works to improve the lives of the less privileged in rural Bengal. His primary research interests are in complex dynamical systems involving physical and social settings. So with that brief introduction, I would like to invite Professor Surjit Sen to start his talk.
Thank you, Vinod, and thank you, everyone. I can be heard, right?
Yes, perfect.
Okay, good. So it is a pleasure and a delight, of course, to talk at IIT Jodhpur again. It has been absolutely exhilarating to spend 5.5 months in Jodhpur in 23, and probably the best time I had among all my visits in the last 30 plus years, 35 years or so. So I'll talk about sustainable cities as ultimate complex systems. Let me just suggest the following. If you have a question, then you might want to post it on the chat the way the system is now set up, and maybe Vinod can then open up the conversation. So I am not able to see the chat, Vinod. So you just keep an eye on that.
Sure. If we can do that, I think.
Yeah. So that then one can ask live questions, and I can respond if need be.
Sure. At the end, we can do it.
Yeah. So sustainable cities are as ultimate complex systems, and I've used a lot of big words here. Sustainable is a big word. Complex system is a very big word. And then when you try to think of what kind of a sustainable city we are talking about, then one probably imagines that one has to think about history, society, culture, education, religion, governance, geography, pollution, ecosystem. It goes on and on and on. So I have listed at least what I thought seem important to quickly list up. I'm sure I've missed a lot of them, but that's what I came up with. I said, okay, fine. So sustainable system, sustainable complex system has to have all these things when it comes to cities. And so, I'm not very good at making acronyms, so I thought I'll seek the help of ChatGPT. And so I took the first alphabets of everything that I had there, not in any particular order, because ordering this mess is not going to be easy. ChatGPT failed to give me an acronym. It completely skipped all these 4 alphabets in the red box out there. So even the super hype ChatGPT couldn't help very much. So this was not very encouraging. Anyway, a few points about our home planet, because that's where we exist, and we need to put the city in the context of the planet. So therefore, the few points about the home planet that I wanted to mention. First is that we should be headed towards a mini ice age right now. Okay, so if you look at the record of the temperature of the planet, going back about 5 million years, you begin to see that in these peaks, in this the first plot, the high peak is high temperature, then the temperature is going down, temperature was headed down, and yet we have this global warming problem. The picture on the lower left is a little bit more detailed. It kind of shows you the ice age and warm up ice age and warm up cycle. And right now, you can see that our temperature, which is supposed to be going down, is actually now going up, as you can see in the solid red vertical line in the bottom right panel, in the panel that's called C here. This is actual data. This is not something that is calculated. And the data source is Professor George Philander, who's a friend of mine and one of the world's most distinguished oceanographers and climate scientists from Princeton. So, and it's a relatively new thing. It's in the past couple of years this thing came around. So anyway, so we are headed towards a mini ice age. We are not going towards the mini ice age anymore. Planet is warming up, which is something that nobody understands, right? I mean, other than, of course, climate change as an issue. The other thing that we are also going through in kind of setting the background is there have been 5 major mass extinctions in Earth's history that we are aware of, certainly in Earth's last 500 million year history. And we are probably going towards a pretty major mass extinction. So in the red circled area on the bottom right, which is the present, as you can see, the data suggests that extinction process has begun. Where it will turn around, we don't know. What is the level of extinction, we don't know. But we do know that many species are going away. We do know that the ecosystem has been massively perturbed by human activities. I'm sure there are other activities as well, terrestrial activities and what have you. So anyway, so that's the backdrop. And of course, I wanted to quickly remind all of us that Earth is a very complex interrelated system. I'm using the word complex system without defining it. So I promise you I'll come to that. And you can see that nothing is isolated, right? I mean, here is a picture of a city that you have, pictures of glaciers, pictures of volcanoes. Earth activities are continuously happening. Earthquakes are happening. Sea ice is changing, going up, going down. Ice caps are changing. Water is getting, polluted. Warming essentially means that the glacier ice caps are going down, which means that water supply is getting affected, soil is getting affected. So there is absolutely nothing we are doing that is leaving the planet unchanged, and that will never be the case. So we'll always be interacting with the planet. The question is, how do we interact with the planet in a way that is more sustainable than what it currently is? And it turns out, of course, that's a difficult problem. So the first real attempt at this was actually a long time ago. It was more than 50 years ago. So Bill Ruckelshaus, who is the gentleman I quote here, Bill Ruckelshaus was actually the head of EPA, the US Environmental Protection Agency. And Ruckelshaus was the first head of EPA. And EPA, believe it or not, began at the time of Nixon. So Ruckelshaus basically wrote something very interesting, and that was in 1989, which I quote here. Can we move nations and people in the direction of sustainability? Such a move would be a modification of society comparable in scale to only 2 other changes: the agricultural revolution of the late Neolithic and the industrial revolution of the past 2 centuries. Those revolutions were gradual, spontaneous, and largely unconscious. This one will have to be a fully conscious operation, guided by the best foresight that science can provide. If we actually do it, the undertaking will be absolutely unique in humanity's stay on Earth. So this was Ruckelshaus's comment, and this man knew what he was doing, because back in 1970, the things I highlight in yellow are the things that his office did under his guidance. First is that pesticide control. He banned DDT, setting the first air quality standards to protect public health under the then fledgling Clean Air Act, establishing standards for cleaner cars and lead-free gasoline, right? Which is what we buy. Building an environmental law enforcement program with teeth, so people could be sued, and creating clean water permit requirements for cities and industries, and building a foundation for so many of the environmental protections we now take for granted. So this is back in 1970 or so when this happened. If you don't take these precautions, we have a clear example of what happened when Mount St. Helens blew its top on May 19th, 1980. This is one of the big active volcanoes near Seattle, as you may know. And there was absolutely no contingency plan for what might have to be done if Mount St. Helens shows volcanic activity. And St. Helens didn't only show much volcanic activity, it just completely blew the top 1,000 feet of the mountain overnight, right? Instantaneously. And that ended up being a massive disaster. But luckily, the area wasn't very populated. The number of deaths numerically was not very large. But the disaster it did had major ramifications. So there is really no way to avoid trouble. We have just lived through a pandemic, so we know how difficult it is to foresee what might be coming and how to adjust and contingency plans for it and be prepared for it, because disasters will happen in life. So let me quickly outline getting into the main talk. So I'll try to define a city for you. I'll try to define a complex system for you. I'll make some observations about selected cities, and I'll tell you more about it as I go along, and a bit about urban underground structures. And then I'll focus on Tokyo for a specific reason, or a set of reasons. I'll briefly mention microcities and governance. I probably won't mention much. And then the issue of unsustainability in the future. The future, of course, will have to be based upon deeper understanding. Deeper understanding means some kind of analysis beyond qualitative analysis, presumably, so quantitative analysis. So I'll try and finish with some insights on the possible modeling ideas that one can pursue. So definition of a city actually is already very problematic. My favorite definition in this case is a city is a place where it is acceptable to be a stranger. It's a very sociological definition. It's a very philosophical definition. But it's a definition that kind of resonates with us, right? I mean, you don't know people, a great many people who are living around you. That's how cities are. And then there are more technical definitions, put forth by the European Union and so on. For instance, it's an urban center with a set of contiguous high-density grid cells with a certain numerical population. 50% of its residents live inside an urban center. An urban center, by the way, turns out to be a rather Western concept. Urban centers are very clearly demarcated in most American cities or a great many European cities. But urban center as such, as a special center, is probably not quite the case in many of the eastern cities. So Western and eastern cities tend to have a lot of differences, which people don't seem to talk about as much. But as I was doing my little bit of research to prepare for this talk, I certainly felt that is the case. So I thought I'll bring it up. Maybe I'm wrong, but I don't believe that I'm wrong. I believe there are good reasons to feel that this is actually a thing. So anyway, let me move on. So basically, we can't really define a city in a very good way. Can we define a complex system? Well, I looked up some definitions, and this is one definition, this whole thing. This is a definition by some reliable people. There is a complexity science center at University of Waterloo, which is not very far from where I am in Buffalo. It's a very elite place, lots of very good people. But, you can see that they have really struggled to make a definition. The only little phrase or sentence that I thought was really kind of important is what I've highlighted in yellow, And complex systems are often referred to as wholes that are more than the sum of their parts. So this is a definition that kind of comes through uh, everywhere when you look into complex systems. So let me just highlight that and move on. Basically, it's hard to. They're complicated systems, but this emergent behavior, which is this whole being quite different than the sum of their parts, is something that other people have also come up with, both from the mathematical and physical sciences, biological sciences, as well as from social sciences. Because when you talk about urban spaces, everything comes in. So highly interconnected systems with often fragile and emergent behavior is what we'll try to think of as complex systems. Uh, Features of complex social system. There's a lot of writing on this topic, a lot of theories that have been developed on this topic. And the writing and theory seems to be around for a long time as well, at least of the order of 70, 80 years, if not longer. Most of it from Europe and the Americas, and that too in North America. Two of the important players in this space is a guy by the name of Joseph Tainter from Utah State University, and of course Jared Diamond, who is very, very well known for many of his books, who is a geography professor at University of California in Los Angeles. Both of them basically bring up the simple issue that complexity tends to build over time in social systems. We invent laws, we invent new procedures, we invent new things to do, we complicate matters, we develop this quote unquote higher order processes that set in, that affect our day-to-day lives. And one of the pitfalls of this kind of complexity building up is that the system ultimately becomes very fragile. It's almost like you are stacking up a deck of cards higher and higher and higher, trying to make the system better and more sophisticated and so on. But then when something little hits, the whole thing collapses. Social collapse, political collapse, we have seen over time, one of the big ones being the rapid collapse of the Soviet Union, as many of us remember very, very well. Essentially almost, over a period of weeks and months, Soviet Union fell apart and the country changed. So that was an example of a collapse of a complex system. Moving on, let me make some selected observations on cities, and I'll talk about Western and Eastern cities. So this is from Wikipedia. And the ones that are underlined in yellow are Eastern cities. Okay, Eastern meaning Asia and so on. And the ones that are in red, they're marked up, basically they're Chinese cities. There is different kind of data there. They're very large cities, of course. And then the ones in pink are cities in Europe and the Americas. Only Cairo is not really completely Asian, but it's an Eastern city regardless. So I've tried to basically list the large cities. And as you can see, it's not so easy to do that. Although it's from Wikipedia, the population where? Population in the metro area, population in the inner city, in the core city. Some of these cities don't have the metro data. For example, Shanghai and Beijing don't seem to have the entire metro population. Japan population in the core city and the metro is well known. These numbers are from 2018. Right now, the numbers are core city is 14 million. Overall, it's about 41 million for Tokyo. But anyway, you can see that a great many of the cities are from the east. And relatively few cities in the list of these top 11 cities are from the west. But the theories and our understanding, should I say, are more influenced by the west than what's been happening in the east. So there is a big mismatch here. And western cities are not necessarily the same as eastern cities. And I want us to remember this point because I think it's a non-trivial point to remember. For example, if you look at Los Angeles, this is a picture of Los Angeles, I think from one of the mountains nearby. You can see very clearly that there is a downtown area, which is essentially straddled with these skyscrapers, right? This is a typical feature of most Western cities. They have a well-defined downtown with an office area, with a business area, and that's like a bunch of skyscrapers. The, the ecology and architecture of the city is such that these areas are not really where many people live. You have drug problems, you have crime activity at night, you have all kinds of things that come up that are characteristic of these cities, and people have modeled them, and people understand them to some degree. People understand how housing prices stack up over distance from this downtown area, how price of land changes, how building heights change, how population densities change. And these models have been around for a long time. And one of the models, if you're interested, you can look at is this Alonso, Muth, and Mills model. And the graphs I have given here are from that. So it immediately tells you that people understand these Western cities. But let me tell you that these cities have very little to do with the Asian cities, because Asian cities are structurally different. The other point I also want to make is that many of these cities are really relatively new. They're a few hundred years old. Uh, for, for the life of cities, few hundred years is a baby. Okay, cities are around for tens of thousands of years. So, and we still continue to live in many of those cities, as we'll see. This is my own hometown. This is Buffalo, New York, 1.3, 1.4 million population. It's a town that is growing very fast. Land prices are going up like crazy. I just read yesterday that the hottest real estate market in America is unbelievably in Buffalo, New York. This is downtown. You can see the same structure. Everywhere outside downtown, you see relatively smaller buildings. Downtown has its own series of problems which dragged Buffalo down after the decline of the steel industry and so on. So, again, a very similar dynamic. Now you see London. London is not a new city. One of the pictures in the bottom, in fact, there's only one picture in the bottom, that is Londinium, that's ancient London, and that's around 120 AD. It's obviously a drawing. But you see that London also has transformed itself, and it has developed a central business district. It has a lot of old buildings, but it's not quite as tight as perhaps the American downtowns tend to be. And on the top right, there is a population density related plot by Mike Patty from University College London. Many of you remember that we had invited Mike to give a talk at IIT Jodhpur, and he gave a pretty fantastic talk from what I recall. But his focus was mostly on just these Western cities, and I've decidedly changed focus from that. This is Sydney, a very different part of the world, but very Western in the way it functions. And you can again see the downtown of Sydney near the Darling Harbour area. This is actually Darling Harbour, just this bunch of quays out here. And here you can see all the tall buildings, less crime problem than the American cities, but it has its own issues. This is Stockholm. Stockholm is quite different. It doesn't have that many multi-storied buildings, and structurally it seems a little bit more dispersed. And I honestly don't know why Stockholm is like this, but I noticed that not all Western cities are the same. But this is Tokyo, and I'll be spending a bit of time on Tokyo, as I said. And you can see that tall buildings and short buildings are everywhere. It's a very, very dispersed structure, and it's a very typical Eastern large city. And Tokyo is a very old city, and it is the world's largest city right now. And it's been the world's largest city for a while. And it's a sprawling area, which we don't feel when we visit Tokyo. Tokyo seems very manageable. There are like buildings that look like office buildings, nice streets, bridges, people walking around. But Tokyo, when you look at the summative effect of Tokyo, it's obviously a very, very massive area. And if you look at Japan, if you look at this part of Japan, you see that the circled area is this main Tokyo, which is in the top right. The bottom right shows not only Tokyo, but the surrounding areas like Yokohama and Chiba and Saitama and Kawagoe and Kashiwa and all of them. So anyway, it's a huge area. So this is the 41 million area, with the red area being more like the 14 million area. So a regular eastern city. This is Bombay. And if you look at Bombay, you see that Bombay is also fairly dispersed with tall buildings everywhere. Yes, there is a sort of a business district in Bombay, but there are multiple business districts perhaps in Bombay also. So I'm personally not that familiar with Bombay. But let me go to Delhi. And Delhi also is a very old city, extremely old city. We don't really know its age from what I've read. And you can see Delhi, New Delhi and Old Delhi are structurally very different. It has its structure, it has its business areas, and so on and so forth. But again, very dispersed. Delhi doesn't just have one business area, right? I mean, and Old Delhi, as you can see, it also looks very, very, very different. The other piece of these eastern cities that is not so apparent in the western city problems is the history of it. So we know that Paris, London, and these cities are very old. They certainly date back to the Roman times. But for Western cities, it's not only just age, but it's also the effect of religion, which has been dispersed over time. The effect of religion in the Western cities have been quite different too. So let me come to that. This is a city that you all know very well, Varanasi. Varanasi, of course, has been around for times that we don't really know. There has been a great deal of work going on, a great deal of work done in the past. For instance, I show a paper on the bottom left that studied settlement pattern and socioeconomic formation in early Varanasi, they say, and that was 2000 BC. That's 4,300 years ago. And this is a serious research work. This is not just words thrown at random. There is a paper by this guy is a very well-known scholar, Rana Singh from Banaras Hindu University, and he has studied a lot about the religious history of Varanasi. And here he pointed out, for example, that this city structure began very differently. The city structure began with these 4 pilgrimage circuits. This is the Ganga River, and this is Varanasi here. And you can see that there are 4 pilgrimage circuits. You can't really see them here, but these dotted lines over here are the pilgrimage circuits. I can certainly see 3 of them, which are like perimeters. And around these perimeters, there are major temples. So the city's architecture historically has centered around these major temples. That's how the city developed. And then, of course, it went through all the historical events. So current Varanasi or current versions of many of these Indian cities are not only very old with the temples, but they also have a structure with the temples. And that structure influenced the business, that structure influenced where people lived, that structure influenced the roads and the development of businesses and so on and so forth. So that cannot be thrown away is what I believe the case. And I should also point out that here is a paper, it's actually in a good journal, Review of Regional Research, and it's current, as you can see, 2022. And this paper basically makes the point that the number of studies that take into account the history of a city has been steadily going up in the last 22 years. So this is from 2020 to 2022, sorry, 2000 to 2022. Plots of number of papers on historical aspects of urban regions that's been captured here. And a little bit about Tokyo, because as I said, I'll talk about Tokyo a little bit. The history of Tokyo shows the growth of Japan's largest urban center, but Tokyo as such is a very ancient city. It is believed that Tokyo may have been founded around 600 AD or so. And Tokyo's older name, it has not always been called Tokyo, it's been called Edo. And that name first appeared in the 12th century. So this city also has its own kind of history, and that has to be taken into account. Now, talking about history and talking about character, you can't get more interesting than Pune easily. So this, for example, we know is a very fast developing, bustling city. People like to live in Pune, excellent climate, and so on and so forth. But I bet you didn't know that Pune has been inhabited, that area has been inhabited since Stone Age. And I am not kidding. And here is this paper, The Stone Age Man in and around Pune, or the habitation of early man in Satchitananda. Satchitananda is actually a building, and this building was built by a Ferguson College professor, and that is this gentleman, Sankalia. And when he was building that building, he was aware that that region could have had historical stuff in it. So he made sure that when he was directing the construction of his home, um, that it be done very carefully. And sure enough, he found a lot of stuff that date back uh, between 50,000 and 250,000 years back. So obviously, we don't know exactly how old it is. But certainly from established documents, Pune as a city has been around since 90 BC. The region has had people living there, God knows how long. And cities have character, right? I mean, you go to Calcutta, it has a character. You go to Delhi, it has a character. And Pune is well known for its character. It even says that on a milestone here. It says, leave your attitude behind, we have our own. So cities are like living, breathing things, and that needs to be taken into consideration as we. And this, of course, are the various faces of Pune. You can see Hadapsar right now. This is how it looks like these days. This is Lakshmi Road, which is one of the central market areas near Lakshmi Road, this one on the bottom right, back in the turn of the century, last century, 1900. This is a garbage dump. That is a problem, and we can't just look away because that's a problem everywhere. Even Tokyo has this problem. Even London has this problem, excepting they hide it differently by making these landfills, which don't solve any real problems beyond a point. And then, of course, you have tremendous traffic, you have all kinds of heterogeneity. And then in the middle of all of that, you have this, Pataleshwar Cave Temple, which is from the Rashtrakuta area in the middle of Pune. How middle? This middle, by the Mula and Mutha rivers. And here you have the Pataleshwar Cave Temple. And, we have passed by this area as we go home from the Pune airport. This is not far from Ferguson College. So this is how Indian cities are. And that's what we know. So imagine what we don't know and how that plays a role in how these cities need to be made sustainable, how these cities need to be improved upon, how these cities can be made modern, as Prime Minister Modi wants to make them by 2047. So the goals that we have are extremely lofty. They're very serious. They're very serious challenges, and we have to not only try and do them, but we also have to know what we are doing in the context of history, in the context of religion, in the context of people, in the context of beliefs and attitudes in society, and so on and so forth. So I just wanted to bring up all these points because not all these points are things that we discuss often. We know about them, but we don't really dig deep very easily because it's hard to do. I mean, I had to do quite a bit of work to to learn these things. Here is a very interesting issue. We all know about slums in Indian cities. We feel embarrassed. We have these slums. We feel worried. We can't solve these problems. But guess what? Every city has a slum. It's, the difference is in the looks. So if you go by whatever is the definition of slums, I read that pretty much most big cities have slums. So here is a slum on the bottom left from Accra, Ghana. They have major slums in Accra. In the middle is Salvador in Brazil, in Bahia. On the right is from Chennai. You can see that, land is a problem. Many of these are structures that are built on land that may not be owned by people. People who live there are generally, they have lower incomes, pretty low incomes. Access to education is a problem. There are often gangs that rule this place. Electricity costs are high because electricity setups are all done, unofficially. So people who sell electricity to them, they're basically doing it in the black market. Everybody knows about it. Most slums are like these. There are all kinds of problems in slums, but people live there. What can you do about it? And it doesn't matter if you're looking in Bombay, you're looking in Chennai, you're looking in Calcutta, you're looking in Accra, you're looking in Bahia, you're looking in even London. The overall problems are very similar. Structurally, they may be a little bit better in the richer countries than it's in the poorer countries. So nothing to be embarrassed about. Reality of life. And guess what? People have been. Oh, I also wanted to make the point that in some of these countries, slum growth is actually going down. Egypt, Mexico, India, Indonesia, it's going down. But Brazil, China, Philippines, Bangladesh, Pakistan, Nigeria, slums have been going up. So this data is a little old now, 1990 to 2007. That's the study I could find. So there has been a good amount of work on the emergence of slums, but curiously, many of these papers are not that old. They're relatively new, which tells you that the focus on slums is relatively new in the space of studying slums and trying to remediate them as such. So this is an interesting paper I found. As you can see, there are people from everywhere, including from India. And it says common to most cities of developing countries are the slums. That actually is simply not true, because if you look into literature on slums, you find there are slums everywhere. Slums in London, slums in New York, slums in Los Angeles. It's just that they don't look the same. So this claim made by this group, at least I couldn't swallow it. Because there is literature I found. I didn't want to bore you with all kinds of literature, but literature I found that contradicts that directly. There are also some very silly papers in very good journals, so to speak. For instance, Science Advances is an open access publication by Science Magazine. And Science Magazine is published by the American Association for the Advancement of Science. It's a very, very respectable organization. I'm a fellow of it. But Science Advances published this paper. It says, Towards Cities Without Slums, Topology and the Spatial Evolution of Neighborhoods, by a bunch of people. And this Betancourt is from University of Chicago. The others are from different places like Los Alamos and some from the UK and so on. But the main claim here is if you give access roads within slums, you can remediate slums. Now you figure out whether this makes sense or not. How many slums have you been to that don't have roads inside through which even cars can go in? Of course, you can't take a Jaguar in there, but you can certainly take a Nano in there. So yes, roads can be widened, but that is unlikely to solve a problem where land occupancy, where waste management, where water management, the infrastructure is not there. So what is this infrastructure that we are talking about? Most of this infrastructure in urban areas rely on underground structures. Cities have an underground life. Okay, all big cities have a very sophisticated underground life. How sophisticated that underground life is tied up with the state of the city. So here, for example, is actually a very nice paper that talks about mainstreaming what can be thought of as sustainable development that can be literally managed and that can go forward without causing disasters everywhere. Uh, and how to build that into a city's master plan. A case of how urban underground space is used. So here is a very interesting plot I wanted to share with you. This is urban underground space used by function in percentage. And again, I draw your attention to Tokyo. And you can see that 55% of the underground space in Tokyo is used for transportation. This is the metro system, the cable lines, the water, management that happens, and all of that. 55% is just for transport itself. Paris, 32% for transport. We all know how good Paris Metro is. if you've been to Paris. Uh, that's what we typically would use if we are in Paris. We all know how transportation systems are in many Western cities. As you can see, a lot of space is reserved for transportation, but it's not just transportation. Transportation is a big piece of it. Utilities take a lot of space as well. For instance, look at Stockholm. Stockholm, utilities take up 41% of the urban underground. In Tokyo, everything combined, other than utilities and transport, takes up 37% of the urban underground. So these are massive, massive structures with their own ecosystems, their own advantages and problems. And here are some of them. So, for example, a very big thing about the underground is it's an isolated area. Being an isolated area, they're not susceptible to many of the external influences, such as noise, such as impact, and so on and so forth. Uh, Energy supply facilities are often buried in the underground. Underground gives you a very stable temperature. It's cool and it's stable, 55 to 58 degrees typically. Underground structures tend to be quite protected in many ways, including from, defense-related situations and so on, including from hazardous waste and so on. It is vulnerable to floods, as we all know, but it's resilient for earthquakes because earthquakes, the surface effects are larger than the underground effects. There is obviously a high cost of construction. So this kind of infrastructure has its own super important ramifications, and they often dictate uh, how advantageous, uh, how likely it is for a city to be able to compete and grow. Operation costs in underground tend to be lower because no outer walls are needed, low cost of heating and cooling, and so on. There's an opportunity to locate close to existing facilities. For example, you can build underground an area where you can't afford to build something overground, but underground is fine. As I said, transportation is heavily used. Construction of underground is always challenging and expensive. And then, of course, waste management, energy management, all of these things have to do with underground. Here is an interesting list of the length, just the bare length in 1 kilometer of surface space underground. So, for example, telecommunication cables use up 17 kilometers of length per 1 kilometer of underground. So, how densely packed these are. Electricity uses 9.3 kilometers, gas uses 2 kilometers, and so on and so forth. So, as you can see, the underground is obviously very important, and this is part of the equation for sustainable development. I now come to Tokyo. So, why did I choose Tokyo? Again, because it's an eastern city, it's an ancient city, a lot of history, huge population pressures. Um, and Tokyo's growth, uh, Tokyo's current state, and Tokyo's future perhaps could serve as an interesting example for us as we look into Indian cities. So, what about Tokyo? Well, what about Japan first? 5 major islands in Japan: Honshu, Hokkaido, Shikoku, Kyushu, and Okinawa. 7,000 smaller islands. It's a small island nation, 380 square kilometers is the size, 1/5 of that of US. Japan has a population of 126 million, not that large, 2/5 of the US, 40% of the US. Uh, most of Japanese people live in the cities. 80% of Japanese live in cities. And 75% of the hinterland is preserved for forests. So it has a very interesting layout. And as I said, Tokyo is a huge city. And here you can see pictures of Tokyo where you can see dispersed tall buildings everywhere along with short buildings. So no really single central business district, but it's kind of a little bit more spread out from what I understood. I've been to Tokyo, but haven't spent that much time to really get a sense of the spirit of the city and the vibes of the city. So here is a case study of Tokyo that I'd like to briefly cover by somebody who was deeply involved in running the city. He was one of the senior personnel in the Tokyo municipal uh, office. His name is this Tokuye Shibata. And I extracted much of these details from a 2006 article he wrote uh, titled Japanese Perspectives on Physical and Social Structures. Shibata is I think, a regional scientist, geographer, planner, engineer kind of a person, very broad background. And so he goes on to make some fundamental points about the history of this area of Japan. So obviously, Japan is a nation with very limited resources. Almost everything in Japan is imported. So that is one extreme case, right? There are basic expenses associated with being in a place like this, which helps us deal with that part of the challenges. Much of Tokyo was destroyed in the 50 plus air raids during World War II. 100,000 plus was killed in just one raid alone on 10th of March 1945. Tokyo population was 7.35 million in 1940, but it basically became less than half in 1945. That's the destruction that Tokyo faced. And so it had to rebuild itself. Post-war Japan had food and fuel shortages. So things had to be done to save the city, to save the area that were not climate friendly, is what I'm driving at. People had to work very hard. And by 1960s, the industries grew and people could afford good life. They were careful, but they could afford good life. By that time, Japan was making more than 10 million vehicles per year. This is 1980 figure. That surpassed the US. 10 million vehicles per year, even now, is a big number. Okay. Tesla is bragging because they sold 1.8 million vehicles, which is great, but rapid urbanization of Tokyo made the population large. There was a period of mass production. This is all tied to growing successful economies, mass consumption, and the resultant wasting of precious resources and enormous garbage generation in a country where resources are not their strength, right? So Japanese became very sensitive to these things. By the time they were already in the late 60s, early 70s, and that became more and more concern for the Japanese. Tokyo population reached 12 million already by 2005. As I said, it's 14 million or so now. And the metro Tokyo was 30 million then, it's about 41 million now. Too many cars, congestion, pollution, time loss, higher costs. So Japan basically turned around and tried to impose this 3 R's principle: reduce, reuse, recycle. And all kinds of basic laws were, triggered. They were drawn up and they were passed. For instance, there are container packaging laws, household electrical appliance recycling law. Your oven, your refrigerator, your dishwasher, what have you, they have to be recycled as much as possible. Food recycling law. Food wastage is very minimal in Japan now. Waste disposal and public cleansing laws came into existence. Law for promotion of effective utilization of resources. Automobile recycling law, 2005. And consumers were encouraged via policy to purchase goods that are easy to reuse and recycle. So even with all these, Japan is not doing very well because of the vexing problem of how to recycle trash. Because recycling trash is an almost non-technological and more sociological process. You have to do it right now with the technology we have with people. It is not easy to do it mechanically. So it turned out that Tokyo, with its own challenging issues, had to face this. And one of the regions of Tokyo, Machida, they tried to do it with citizen involvement. Okay, this was no longer the less privileged helping me, it's I helping myself. That attitude had to be brought in. And they managed to get up to 25% recycling by 2000. I don't know what the current number is. I haven't found literature on this yet. Basically, these people actually suggested that if you want to reuse, recycle, and all of that, you have to have regions of the city take over. You can't have a central office that is managing for the whole city. So I was thinking about our microcity discussions, and so this has to be why the concept of microcities must remain valid and must be pursued a little bit, because if you want to do this kind of detailed governance, if you want to deal with the bull by the horn, you can't deal it in large scale. You have to divide and conquer, and the microcity is one of the ways how to set up these microcities in existing structures and still respect what they have and be able to empower them to move forward. Some will do better than others, but that's how life is. Tokyo has also other problems in terms of recycling. For instance, people can't do much in their homes. The homes are very tiny. Environmental pollution is still there. For example, there is a lot of acidic wastewater pollution, and this is in this river, Watarase River, and that's because the area has very heavy copper mining activity. So copper and zinc and all these get into the water, and that has damaged the farmlands and the crops and livestock and people. And these are the three major diseases that people in the area have: lung disease, renal impairment disease, and bone disease. Tokyo also tried a centralized garbage disposal approach. One area of Tokyo, this Koto area near the bay, but Koto people revolted. They basically said, we don't want all of Tokyo's garbage here, forget it. And so Tokyo still hasn't solved the garbage dumping problem very well. They tried to make garbage islands in the sea, but that has created other environmental disasters. Landfills they don't want. And right now, only about 20% of Tokyo's waste is recycled, and 75% of the waste is still incinerated, causing a lot of toxic pollution. So clearly, they have not really been very successful in spite of their best efforts. So this is one of the most serious problems that we face. So unsustainability issues that we are dealing with. One of the other problems that I didn't touch upon is that of particulate matter. So there are studies done on particulate matter in cities, fairly detailed studies. And this particular study that is relatively new, forget which year this was. I think this was 2022. I can't see it here. Anyway, so this particular study is on Genova, Italy, and areas in Genova that they looked at. There's Brignole, Cornigliano, and Multedo. So these areas they studied, PM10, which is 10 micron size particulate matter, 2.5 micron size particulate matter, PM 2.5, and PM1, 1 micron size particulate matter. Where they come from? So in terms of, how much of this you see in the sea, how much of this you see in the soil, how much of this you are seeing from heavy oil combustion, how much from traffic, blast furnace, and so on. And they looked at this in some depth. I'm not going to go deep into it, just point out that the highest amount of contamination is in PM10 in this area. So as you can see, it's about 1,000 nanograms per meter cubed is this horizontal line here. And some of the higher density of elements here is iron, for instance. You have calcium, you have sulfur and chlorine, you have sodium, silicon, magnesium, and aluminum. So these are spread all over, okay? So very common contaminants and obviously causing all kinds of health problems. So somehow our air quality improvement has to do with improving our ability to manage these pollutants and getting rid of them as much as possible. Another interesting recent paper, pollution assessment of heavy metals in soils in India, and ecological risk assessment. It's a very comprehensive study. I actually thought the study was great. And in this study, you basically see something which is quite clear. there's a lot of detail given in the abstract about what elements they found um, are problematic and exceed the safety levels. For instance, zinc and lead. By the way, this is pretty extensive data, 1990 to 2020 almost, so it's almost 30 years. Um, then you have arsenic and copper, you have cadmium, but the biggest risk in India is from cadmium. And cadmium turns out to be the most problematic in India right now. So these are the areas from where sampling was done. So as you can see, that the soil collection sites are very, very extensive. They're all over India. So it's not really a biased study. And they basically report that the contamination factor is the highest for cadmium. And cadmium is very highly present in urban, suburban, and riverbed soils and soil in general, um, as you can see here. Of course, there's cadmium in industrial soil and agricultural soil and so on, but uh, the urban regions have big cadmium problems. The other problem is arsenic, and that, of course, we know. I mean, some areas have natural arsenic. For instance, the Gangetic Plain has natural arsenic, but it's still a problem for us humans regardless. And there is a very nice review article I found from a group in Nigeria, and they talk about how to remediate these kind of problems. What are the current technologies for remediation? So I try to capture and mention that just to give you the sense that work is currently underway to figure out what are the best possible ways to remediate this. This is a relatively old article. It's about 12 years old, but there may be newer papers out there. Um, Another important problem that we often bring up, but we don't really discuss in great depth, I suppose, is drug pollution, which is really threatening the world's rivers. And now the number is like some 40% of the world's rivers could contain harmful levels of drugs. So this is beginning to have a very, very large impact, and another one of those sustainability recycling problems that need to be taken care of. So uh, lastly, I want to also quickly mention a little bit about sustainable building materials. I know IIT Jodhpur is very involved in this, so I thought I shouldn't skip it. And here the main point is what are the good materials to use? Of course, good materials to use should not be carbon heavy, because that carbon will be released. And as you can see, some of the very common materials that you see in many buildings, especially European buildings, steel, bar, and rod. So steel use is very common. Steel use is very problematic. American construction also relies a lot on steel. But you can see many of the materials here, they have low embodied energy, which means they're relatively inexpensive to make energetically, and also very low carbon content. For instance, basically limestone, stone, gravel, and so on. But by the time you get to concrete and so on, it's already going up, but nevertheless, they carry relatively low amounts of carbon. Once the carbon amount starts to go up, that is seen as a problem. So anyway, so that's a sense, and of course, this is where material science comes in. So what about the climate? How are things getting affected? What's being done? Well, a very beautiful picture here that I found online. This is a picture of Berlin. And as you can see, there's just about as much buildings as green here. Berlin has made a very big effort in trying to introduce greenery in the urban environment. And it's obviously been good for them. That's what the discussions were about. If you look into the model of Manabe, Siyukuro Manabe, who won the Nobel Prize in physics in 2021, about climate change and so on, Manabe's model basically points out that there are two things that's going on. One is that solar radiation hits the ground. Part of it is reflected back, or scattered back is a better word. Part of it bounces off the particulate matter, which includes clouds, because clouds have water vapor, which is also some kind of particle, I suppose, not solid particle, but liquid particle. Particulate matter essentially bounces it back down to Earth. So once the bouncing back down to Earth is higher, then of course there is greenhouse effect and warming and so on and so forth. So therefore the particulate matter aspect and is very important. And of course soil pollution is related to atmospheric pollution, because whatever is in soil will sooner or later come out, and that will get into the atmosphere. So the modern architecture that I was looking at, from the urban planning point of view, mostly seems to be bringing in the green and the blue being strong use of, healthy use of water, river water, lake water, whatever, and the green, of course, being using the land in such a way that try to mesh the structures in as much with the natural environment as possible, so as to minimize its effects. So what about the future? This is the last slide, almost the last slide. So let me circle back to the words of Joseph Tainter and Jared Diamond. They both said that you have to manage complexity. If you don't manage complexity, there will be a collapse. That was social collapse, but who's to say it's not a collapse of the ecosystem? It's not a collapse of the structure of the city itself becomes non-functional. Cities became pretty non-functional during COVID, so we don't have to go that far back to see when cities can become non-functional. So where do we start? If we want to change things, if we want to make things better, where do we start? Well, we have to start with the basic unit of, uh, of the space, which is a household. Start with people. People make households. 1%, 2%, 3%, 4%. What kind of households are there? How do these people live? What kind of problems do they have? What do they do? How do they make a living? Where do the kids go to school? Is that education helping? Are they developing a good value system when it comes to taking care of others as human beings? Are they developing a good value system when it comes to taking care of the place where they live? Are they kind? Are they caring? Are they educated enough to be able to contribute in a society where life is getting perhaps a little bit more complex by the day? So any kind of really serious study, it seems to me, has to start with that basic unit. And then from the functioning of the household, what a household can do, how it is recycling water, how is it wasting stuff that it cannot make use of, what are its habits, what kind of healthcare structure is there, does it use the underground aspects of the city well, uh, all of these, the roadways well, what kind of transportation is being used, is that environmentally friendly, are there public transportation, is that environment? So all of these things tie ultimately into the the family. So as Tokyo example reveals, that it's incentivizing the family's behavior, the human behavior, that's got to be a key part of the puzzle, if not the key part of the puzzle. Okay, so that's one thing I wanted to bring up. There is also the issue of what does technology do to society? We get very heady about technology, and we should be. Technology is incredibly important and useful. But what are technology's ramifications? What about security? What about the fact that we are getting perhaps overly dependent on things that we don't need to be dependent on? What about pollution? All of these silicon-based technologies are causing enormous pollution. How do we deal with that? Many of these things are easier to ignore, of course, because we're going ahead. But the cost, as the Japan example, the Tokyo example brought up, the cost is enormous. So with that kind of points, I want to thank you all, because as Vinod mentioned, I'm a physicist, and I wouldn't be doing these things unless I was in Jodhpur and unless I was dragged into this and educated on this and made excited about this by my friends out there. So thank you, thank you, thank you for giving me a chance to lay out all these big issues to you, just to hopefully get you a little bit more excited. Thank you. I'll stop there.
Thank you very much, Professor Surijit. It was great hearing from you on the history of cities and the need for holistic perspective while thinking of the future of sustainable cities. Right? So with that, if you have any questions, I think we can take it up now. No questions in the chat box. So probably the audience, I think they can unmute and ask the questions directly.
If they can unmute, because I think Dr. Goyal was saying he was having trouble unmuting.
Okay, let me check.
Maybe
It seems like we don't have any other questions.
Okay, no problem.
Right. So with that, just check. I think, yeah, there is one question.
Okay. You guys can always email me. Everybody has my email. But the whole idea is that there are aspects to urban development and urban environments and urban sustainability and so on that are deeply, deeply sociological at a fundamental level. And hopefully I've been able to tell you a little bit about where that sociological aspect and how it connects, how it intersects with the engineering and the science and the technology
Right.
kind of comes in, because this is not easy to do and will never be easy to do.
Right. I think there's one question. Yes, please.
Am I audible? Dr.
Yeah, you are audible.
Yeah, you're
Yes.
audible.
I'm Saurabh. I'm a social psychologist.
Oh, wow. Hi, Saurabh.
Hi. I don't know how to on my camera. I'm sorry. So it was very difficult to even unmute. So I have a couple of questions, and probably it is late for others for dinner, but still I will ask. My first question is that you are saying that we should one way to deal with this thing to incentivize families in some way. I need to ask you how, because there are certain, I was in China for some time and all these things, that they are changing the policy, they are facing the big policy with the population, they are dealing growth coming down and all these things. So now they are bringing up the three-child policy and all these things, and they are giving a lot of incentive for that thing. People are not taking those incentives. So even when the government is giving some kind of incentive, how and why means what are the ways when we how we can make them that they will use those incentives and follow the policy a certain thing, because giving the incentive is probably just a policy level, but somehow the policies are failing even in that level as well. You just give the when I was in Delhi, I think so 9 or 10 years back, there was they started a footbridge in certain places, and people were not using the footbridges. So they started with some scheme that you will cross this thing, that you will get a lottery or coupon kind of thing. And every week or every month there was some draw of the coupon, and then you can win certain kind of thing. But still people were not using those things. So that is the one thing that I want to ask: what kind of incentive and how to make sure that they actually using this kind of thing. Should I ask the second question as well?
Let me quickly respond to this to the
Yeah.
extent I can. It's a bit, I don't want to forget about it. So this is, you raise an extremely important question, because incentives can only work if they fit people's behavior, if they fit people's mindset. So, for example, education is a huge component of it, which is often underplayed. How many times do you hear that there is a real problem with waste recycling on the radio or on the television or in social media that is pertaining to your city, right? If you have a city newspaper, the city newspaper will hardly ever talk about it, because it's, why? Because it's not popular. So things that are difficult, vexing, and unpopular, perhaps, they have their own issues in terms of getting into the mindset. That's why the education process has to be brought in. Everybody's got to go to school. Everybody's got to go through education. So that kind of background, I think, must be done, and this is one of the things that Japan has tried to do, is what I understood. The other thing that you mentioned is what kind of incentives. So, for example, if you tell me take out every plastic wrapper and put it in a special bucket that the city will give you, um, and if you don't do that, you will fine me, which is impractical. The other thing is, you can say, if you keep doing it, you can, maybe you don't want to put it in a receptacle, you want to take it to a store and give it back, and when you give it back, you'll get 30 cents back for it, if it's, let's say, so and so weight. I will actually do the 30 cent back for it business. I will probably not be very good about putting it in the receptacle. So the detail of the incentivization is very important. And there is a good example of how it has worked. For example, back in Oregon in the 1980s, you might know this. I wanted to mention this, but since I didn't want to take up too much time because of the hour, they started this bottle recycling. So the beer bottle and so on and so forth, your Coke bottle and whatever bottle you have, the cans and bottles. So once you use them and you take them back, they give you 5 or 10 cents per bottle. By the way, you pay for it when you buy. So when you buy, you actually pay for the bottle separately. So it's that part of the money that you get back. That's an incentive that has historically worked very well. And as you may know, all across US, you have this thing working, and very few people actually throw cans out anymore or bottles out anymore. It's just become uncool to do it. So yes, anyway, so that's the answer for part of it. I'm sure I've simplified it a lot. You had another question, I thought, please.
Yes, one more question. Actually, I have a mini question, but I think some people will get angry if I ask one question. One question, as being a psychologist, what like incentive can be a solution, but see, the thing is that when we look at the motivation, it is always external motivation. How long it can be sustained, the thing, until unless this motivation comes from the inside. Like what is you are saying, education could be a one source, but again the problem is that where what we are teaching and where we are teaching, how many times we hear and all this thing. The whole idea of the incentive is, as being a psychologist, what I found is the problematic is unsustainable in the nature itself. The moment you take it out, make it different, or maybe you cannot give the money all the time kind of thing. You have to, somehow you have to end this thing. And then the whole thing, people will go back to normal. They probably, I don't think so. It's a sustainable model itself is an incentive thing. That's probably is my perspective. That is one thing. Second thing is that when your definition of the city, when you mention your favorite definition, the whole are more than the sum of its part kind of thing. We
No,
also use in
that's a definition
psychology.
of a complex system. That's not a city.
Oh, that's a definition of complex. Okay, that's not. Oh, sorry. So, okay, that was a complex system. Okay, fine.
Mm-hmm. Yeah, yeah.
I think so. You have mentioned in the city in that slide.
No, city I mentioned before that, and what I said is that in the city, it's you have more people who are strangers to you. That was the sociological definition that I found.
Okay.
Yeah.
Okay.
But
Yeah,
complex
sorry.
system is where the emergent process idea that you have, you have these pieces, and the pieces add up to
Yeah,
behavior.
right.
Yeah.
Yeah. Now the thing is that also when in psychology, so we also use this thing, especially there is a term, there is a psychology school, the Gestalt psychology, in the base, which based on this principle, the whole is more than sum of its part, is basically talk about the perception. And
Absolutely.
generally the perception comes in very like a it's not a very high level processing, it's very simple level processing. High level processing, thinking, another thing. So when you say that there is a complex system, in psychology generally we use it as a simple system.
Mm-hmm.
The whole of the part and something like is we use as a simple system kind of thing. It's because perception we don't believe is a very high level thinking, a high level cognition kind of thing. At least we define in a very basic cognition, and then comes the thinking and the decision, and all this thing is a complex, we can say.
Right.
Anyway, that is a different view of thing. Probably we need more. The one question I want to ask about the China, you mentioned that the slum areas are increasing. You mentioned in one paper,
Yes.
but the China is a very developing, very means it's very high developing rate, means the growth rate is very high. So what could be the possible reason that the slum areas are increasing? Means, can you put some light on that thing?
I honestly don't know, Saurabh, but what I understood, what I gleaned from reading, and what I gleaned from talking to my Chinese colleagues and friends, is that the China's growth is fundamentally very different than growth in other places because it has been very deeply politically managed. So the cities in China, the way they have not grown naturally. The people have been evicted from their land. Their land has been basically forfeited by giving them money, and they have been moved to areas where they essentially would be able to afford to stay. So therefore, China's problems are structurally very different. For example, I had a student many years ago. He told me that he inherited a half a flat, basically share of a flat, shared with his brother from his father. His father was a professor at Shanghai Jiaotong University. He was a fluid dynamicist. Didn't make all that much money, but Shanghai at the time was cheap, and he bought a few flats. He had 3 or 4 sons. Turns out that flat that he owned when he was my student, he said, I said, how much is it worth? He said about $150,000. And this is, I'm talking 2002, 3, 4. So he said, so I told him, it's a lot of money for you. He said, yeah, it's a lot of money. I was talking to him in something like before the pandemic, 2019, I was visiting him. And we had a discussion about his flat. That particular flat, his share was 1.5 million. So why? Because it is Shanghai, because of its location, and because Shanghai has been artificially built up and the prices have been jacked up. So China's problems are a little bit hard to study unless you get data. And you may have access to that. I don't. I don't see publications on it. And many of the things that you see are. Now, regarding the issue of perception being of course, perception is complex. I mean, we can't describe perception in any quantitative way. I have a colleague here who is one of the top hearing experts of the world. And of course, most of the hearing is in the brain. And I've worked with him over a period of time. And one of the things that you learn is that our hearing-related understanding, hearing-related, interpretation, and so on, how much of the perception circuit is involved there. So from a biological perspectives, I don't know how one understands them now. But of course, psychologists have made tremendous amount of progress in this field. So it's a difficult area. But yeah, I mean, and the third point that you mentioned regarding incentives, I think incentives both work and not work. Question is, what is the detail of it? I mean, I gave you an example of an incentive that has worked in the US across the board. Because if you buy a Coke can, if you buy a beer bottle, if you buy, some soft drink bottle, the way it is priced is you pay for that bottle's cost separately. It shows on your bill. So you may not want to recycle one bottle, but you're going to use that. And when you have 100, 150, 200, 300, 500 bottles in your garage or in your home, it becomes unsustainable. Are you going to throw it away and throw away the money, or are you going to recover it? Of course, not 100% will recover it. But I don't know the numbers, but I know of very few people, typically young people, who haven't figured things out yet, who are not paying for their own things yet. They are the only ones who throw bottles. Nobody else would throw a bottle here or a can. So question is, how is it being done? Now, if you, for example, we all get surveys to do, right? You do this survey, you'll get, you'll be put in a draw for an Amazon coupon for whatever dollars. I never do them. I don't need that money. That's not sustainable to me in terms of doing a survey. If you want to do a survey, You actually go to people and do it, just the way Pew does it. And that works. That's what defense departments use. They don't use many of these online surveys with this Amazon coupon or whatever coupon. So there are both models. I think but it's a difficult question to know, obviously, which one may work and which one may not work, because human behavior is not predictable as we know. Anyway,
Thank you,
thank you
Professor.
so much.
It was
Thank you
really
for it.
wonderful thing. In the last thing, just I want to suggest you a book because you are probably interested in this kind of a thing. Because you are
Please.
learning. There is a book, probably you must have read it. It's a Makkah written by Jalaluddin Sardar.
Acha, no, I haven't.
The whole is a very thick book is about how the Makkah has developed over the city and
Oh,
over the period of time from the release. It's wonderful book. Means there's just maybe more than 200, 300 pages, and I finished in 3 days. And it's so good that I want to go to Makkah, but somehow I know that the religious, because of my religion, I cannot enter in the Makkah. So I
yeah,
cannot.
probably
But I
not. Yeah.
visualize the by reading the book and by reading the history and all this, probably it can.
I'll
Do you
take a
have
look at
any
that.
such kind of the reading for the Delhi? I never find any such kind of reading which talk about the city, like a biography from the city's perspective, or any
I
other
haven't
city.
found it. I haven't found. I mean, I have obviously. Wikipedia says that it was very much around during the Pandava time. That's what Wikipedia says. But I haven't found any literature on this yet. I mean, I'm still looking. If you find something, if anybody finds something, I'd love to know. But because it's very important, I think you got to know the history of a city, because Eastern cities have really massive histories. I mean, Western cities have much thinner histories for the most part. So just because the Western scholars don't give too much of importance to history doesn't mean we need to do the same. Actually, we should do the reverse. And in fact, as I gave in the example of Varanasi, the whole structure of Varanasi is based upon these pilgrimage circuits. That is the structure. It is still embedded in there. And if we know that and if we use that, maybe things will be easier to develop and plan. I don't know. I mean, I'm just throwing the idea out.
Thank you,
But
Professor.
thank you. Thank
That's
you.
all from my side. Thanks. It was wonderful.
Thank you. Thank you for your kind words.
So if there are no other questions, let us once again thank Professor Surjit for that wonderful talk.
Thank you.
And,
It's getting late for you guys. It's past 8 o'clock. Almost dinner time. People are getting hungry, I think.
Right.
All right. Thank you so much.